Yeah, the perception and the tracking is happening while it brings its arms around.
There we go.
Okay. Yeah, alright, so that's the knot right there. And as you can see, I mean these things are just in the initial stages of research, right? So we want to make these things as robust as possible so that they work on any scenario that we throw at. Let's look at laundry folding. Okay, so the idea is there's a crumpled article of clothing in front of the robot, and the robot completely by itself has to figure out, how do you fold it and put it away. And so this proceeds in several phases. So the first phase is essentially the robot is trying to manipulate the object. So you noticed the first time it tried closing the gripper, it couldn't hold on to it, so then it tried it again. But this it is doing completely autonomously. So now it's performing a set of motions on the object, trying to figure out what it is that it's holding and how it's holding it. And so this it does by looking at two things. It holds it up by one gripper and looks at the lowest point on the article of clothing. Then it holds it up by both grippers and looks and fits an outline to the article using image processing and computer vision techniques. So what you see here is essentially for a towel, the robot is trying to identify the diagonally opposite ends of a towel so that it can hold it up. It performs these motions. It's just trying to straighten the kinks out. It drags it across the table to do this. And then now it knows that the end that's left is essentially the other end of the piece of cloth. So it goes in, grasps it, and holds it out. So it has to go through these bunch of motions, because then clothing could be in infinitely many configurations, right? And so it wants to make
autonomous. This movement.
Completely autonomous, yes. So it's doing the vision, the perception.
And it knows that the piece hasn't flopped over.
Yeah. So it's figuring that out on its own. So it's doing these motions to try to get it to a particular configuration. So once it gets here, it brings it to the second phase. So the second phase is what it's doing is essentially trying to lay it out flat on the table so that then it can go in and start folding. So to do that, it first in the initial phase it first got hold of the two diagonally opposite ends of the cloth. Now it gets hold of 2 points along the single edge. Right, and so it's straightening it out. It's and then it'll bring it down on the table, and then it'll lay it out. And again, because the robot has no knowledge of what the cloth's doing and what it can possibly do, what the surface is, then it starts straightening it out. So then, right now you see that it's not completely flat. So any fold that you attempt with this will not succeed. So then it comes in, and then it'll flip it over. yeah. So now it's laid it out flat, and so that's essentially this phase where now it looks at the article and figures out, this is the configuration that I'm dealing with. Now comes the hard part of how do you actually fold this thing. And this could be a towel, this could be a shirt, this could be a sweater, it could be anything. And so you could perform a bunch of motions to try to fold this thing. So the approach that we came up with is a geometric approach instead of a physical one. So the idea is the robot always does motions where part of the cloth is horizontal and part of it is vertical. Now this is a restricted set, but then you can plan for motions and how to fold it, and this is rich enough to work for shirts and skirts and sweaters and trousers and even onesies. So yeah. So it's doing the planning on the fly. I mean, it wasn't. So there's no hand-coded motions here because you possibly couldn't do that with cloth. And that is one of the things that we're trying to do. Variability, where even if you try recording motions and playing it back with variability like this in deformable objects, it will fail. So then now it goes ahead and folds it.